All right, I'm going to go over your mid-unit, second mid-unit from Unit 5. Number 1 asks, which graph shows a non-proportional linear relationship between x and y? So I've written here, non-proportional doesn't go through the origin. So as I'm looking through these graphs, I'm going to identify the origin. If the line goes through it, if my graph goes through the origin, it's not the correct one. So goes through it, not correct. Doesn't go through it, that one's correct. So I've marked B, and I'm going to look at the other two. My graph goes through the origin, and then my graph goes through the origin. So that's why I chose B, the only non-proportional graph on here. Number 2, the graph of a linear function is shown on the coordinate grid. What is the y-intercept of the graph of the linear function? So I've highlighted my y-axis. My graph has got to intersect or cross the y-axis at one point. And if you see right here, I've marked the point where it's intersecting the y-axis, and that's when y is -5. So -5 is what you should have for number 2. Number 3, which table contains only corresponding x values and y values where the value of y is 3 less than the quotient of x and 2? So this was really similar to the one that was on the review. The only difference was the review one said 3 more than, and this one says 3 less than. So I've broken it up. Y is, that's my y equals. And then the blue is the 3 less than, so that's where I've got the 3 less than. And then the quotient of x and 2, that's right here, x over 2. Once I have my equation, I just need to substitute my values for x into the equation to determine which of these tables is correct. So they all have the same x values. So I started with 7, and 7 divided by 2 is 3.5 minus 3. Well, 3.5 minus 3 gives me just 0.5. And there's only one of them that has that. I'll work one other one so you can just see that it works for the next ones down. 10 divided by 2 is 5. 5 minus 3 is 2. So 10 and 2. And if you substitute 14 and 17, you'll find that your y values match. So A is the correct table that works for the situation. Sorry about that. Number 4, which linear equation represents a proportional relationship between the values of x and the values of y? So remember, proportional goes to the origin, so that's when my b equals 0, so I should not see any value outside of my slope and my x. So I've identified we have a value that it can't work. We have a value right here. We have a value. Y equals 24x is the only one that has a proportional relationship. Number 5, the two lines graphed on the coordinate grid each represent an equation. Which ordered pair represents a solution to both equations? So I've identified the point where they intersect, and x is -3 and y is 3. And remember, when you're writing your ordered pair, x and then y. So -3, 3, that is the correct ordered pair for that. Number 6, the graph models the linear relationship between the charge for a trip and the number of miles driven for 2 taxis. Based on the graph, which statement appears to be true? So here's my graph, and then all these scenarios are talking about when you have a distance of 5 miles. So when we have 5 miles, I found that point. This is where they intersect, and they have the same x and y values. So 5 miles is going to cost $20 regardless of which taxi you're going to be in. So the charge for a trip with a distance of 5 miles is $20 for both taxi 1 and taxi 2. And then looking here, $5 less, that's not true. Can't be determined, well, we can determine it's right there in the graph. And then 5 greater is not correct either. They are the same cost of $20. Number 7, in which table do the values of x and the values of y reflect a non-proportional relationship? Remember, they can't go through the origin, so they cannot have the point 0, 0. So all I did was determine when x goes up 1, how much is y going up, and then I worked backwards and subtracted until I got to 0 for my x, and I saw that 0, 0 was on the table there. Same thing here, determine how much for every 1 my y goes up, and then I subtracted. So subtract 15, until I have my x is 0, and again, my 0.00 is on there. Next table, for every x value going up by 1, my y goes up by 2. So when I subtract my 2's and my 1's, I get 0, 0, so that's proportional. All right, my next one here. For every x going up, I go up by 6 with my y. So I'm subtracting 6, and I had to work a little ways down, and I found the 0.07. So D is not proportional, and that's the one you should have chosen. Number 8, Camilla has 15 toys in her toy box, and she adds 2 new toys every month. Based on this information, which representation shows this relationship between the number of toys Camilla has in her toy box, Y, and the number of months that have passed, X? So 2 toys every month she's adding, so that's my slope, right? 2 per month. And then she already has 15, so that's our y-intercept or our starting point, and that's our b value. Once I have my equation, I can start looking here at my tables. So this one right here, 1 and 17, that works. 2 times 1 is 2 plus 15 is 17. So that one worked. But then I need to input 4 for x. 2 times 4 is 8 plus 15 equals 23. So that doesn't work. Here, these values are all over the place. That's not even in any way, shape, or form correct. So that was an easy, not going to work. Here, we're starting at the origin. So it's saying that she's starting out with 0 toys, which isn't true. We need to have a y-intercept of 15 because she starts out with 15. Which leads us to C, which starts at 15 and it goes up 2 for every 1 month. So your correct answer was C there. Number 9, which graph shows a proportional relationship between the values of x and the values of y? And here's the 2 big things you need to remember. Proportional goes through the origin, and we're looking for a straight line. So here I've identified the origin. Does it go through it? It's not proportional. Here, it goes through the origin, but it's not a straight line, so it's not proportional. C goes through the origin and it's a straight line, so that is proportional. And then D is not proportional because it does not go through the origin. It has to be both, going through the origin and a straight line. Number 10, Esmeralda earns $50 each day that she works at her aunt's hair salon, plus a $15 monthly bonus if she arrives at work on time every day. Last month, Esmeralda was on time every day. Which equation best represents the linear relationship between x, the number of days Esmeralda worked at the hair salon last month, and y, the total amount of money she earned last month? So every day, that's my $50 per day, and there we have a one-time bonus of $15. So I built this, and I used my y equals mx plus b. So this is my unit rate or my slope or any other name. This has got lots of different names. My per month, right? That's going to go there for my slope. This is my y-intercept of that one-time thing that's happening. No matter what, I'm going to get that 15 for showing up every time, every day on time. Then I'm just going through here. This is not in the right form, and this is not in the right form. It should be y equals. So that was easy to say, nope, those can't work. Then I just need to make sure that I know which one I'm going to get per day. Sorry, it was per day. I said month earlier. So $50 every day, and then $15 once for being on time every day. So D was your answer. And then here you should be telling me what you needed more help with, and I hope you did well on the test, and definitely make sure to give me that feedback.